Hello friends, this is Divya Goel. Welcome to my channel Creative Study with Coding, where we'll learn C coding in an effective way from day 1. In this video, I will start a new very important topic called pointers in C. Then I'll discuss its type, after that its uses and how to use pointers with array and function. The best thing in this video are examples and demo which have been very useful for learners to understand quickly. So these are the topics to be discussed over here. Pointers in C, types of pointers, use of pointers. Pointers are used in swapping two numbers by using call by reference, and we will understand it by differentiating between these two ways of calling functions, that is call by value and call by reference. Further, pointers are used in accessing array elements. Pointers are used in dynamic memory allocation. That will be discussed in next coming video, but I'll give a short glimpse about it in this video too. Pointers are used to implement data structure like different kinds of linked lists, etc. Data structure is itself another very important subject to be read. Pointer to array and pointer to function will be discussed in detail in next video to keep this video short. So let's get started quickly. But before learning pointers, let's take a short revision of variable. If I declare a variable a of type int and its value is 5, that is int a equal to 5, and we know that a variable is always stored at some memory location or some memory address. Let's suppose it is 4000. Then it will look like this. Now let's understand it clearly how it is stored in memory. Since you are studying computer programming, and in computer you must have learned everything is stored in machine language, that is in 0-1 format, where 8 bits form 1 byte and 1 byte represents number between 0 and 255, that is combination of 0 and 1 of 8 bytes like 001 001 00 0011 0010, etc. The size of memory vary from machine to machine. Now let's suppose in my computer memory is of 30 bytes, so it will store 30 bytes of information obviously, and each block of memory will store 1 byte of information. Let's assume that its starting address is 100 and ending address is 129. And if I wanna store an integer of 2 bytes, this will occupy these two blocks 100 and 101. First block is called initial address or base address. Now let's understand what is pointer. Pointer is a special variable that stores the address of another variable. It always points to the base address of the variable which it points to, and it also occupies some address in the memory. It is not its own data type. Now in this picture you can see a pointer holding base address of a variable a which is 100, and it is itself stored at location 128. This is syntax of a pointer, data type asterisk pointer name, but pointer has not its own data type you just read. So what is it here? What does it mean? Let's understand it. Since pointer holds the address of another variable, so it points to that variable. So data type will be the type of the variable that pointers points to. So pointer p is holding the address of an integer variable over here. Therefore, its type will be integer. So we'll write int and it is read as pointer to integer. Similarly, char asterisk p is read as pointer to character. Float asterisk p is read as pointer to float. And struct asterisk p is known as pointer to structure. Pointer could point to function, array and pointers too. This is how a pointer is declared, and here pointer has been initialized by assigning the address of an integer variable a. Since it is now holding the address of an integer variable, so it is pointing to that variable, thus its type will be integer. These both of the steps can be combined into one, or above three of them can be combined into one single statement. Thus here we can see that pointer p is holding the address of a variable a, so it is now pointing to that variable. There are some points to remember about pointers. It has not its own data type, and its type depends on the variable that it points to. An asterisk sign is used before it, then it is termed as a pointer. Pointer must be initialized after declaration with providing address of the variable. So don't forget to initialize it, otherwise it will show error. And such type of pointer is called wild pointer or uninitialized pointer. Ampersand is called address of or reference operator that is used to assign address of a variable to a pointer. And in next statement, asterisk p is called dereference or value of operator that is used to print value stored at that address. In this program, A has initialized with 10, P is a pointer, and P has initialized with address of A, so P will point to A. And in these different printf statements, we are printing value of A, address of A that is stored in P, address of P, value at P, and address of A. And you can see address of A that is stored in P is same. And format specifies how much memory is to be used in bytes, and it varies machine to machine and shows distinct ranges where U stands for unsigned integer, X for hexadecimal representation, P for pointer format. Let's understand these in this example. In this program, pointer has been used and you can see all the three statements have been combined into one, and unsigned int has been used as well. Compile and run it. Here first 10 is value of A and second 10 is value stored at B, and these 65524 are representation of unsigned int. Here X has been used for hexadecimal representation. Compile and run the program to see the result. Now you can see the result over here. Here in this program, P has been used for pointer representation. Compile and run the program to see the result. Here you can see the result of pointer representation. Now let's see types of pointers. It is of four types: wild pointer, dangling pointer, null pointer, and void pointer. Let's learn what is wild pointer. We've learned in this video about it that an uninitialized pointer is known as wild pointer, and it's a type of error that occurs when pointer is not initialized. So to avoid it, do initialize the pointer. In this example, pointer P has not been initialized, so it is a wild pointer. But if we initialize it by passing address of a variable x, now pointer P is not wild pointer anymore. But there may be other way to avoid wild pointer, like if we dynamically allocate memory to a pointer and assign some value to it, wild pointer can be avoided. Now let's see what is a dangling pointer. When a pointer points to a memory location that has already been deallocated or freed is called a dangling pointer. This statement allocates memory dynamically, and this statement deallocates memory. After deallocating the memory, pointer is still pointing to that location. Such type of pointer is known as dangling pointer. To avoid it, initialize the pointer to the null value. If we simply assign the null value to the pointer, then the pointer will not point to the deallocated memory. Assigning null value to the pointer means that the pointer is not pointing to any memory location. Now we came to know that wild pointer and dangling pointers are that pointers that do not point to any valid object. So these are special cases of memory safety violations. Third one is null pointer. Null pointer is a pointer that points to nothing. If we don't have address to be assigned to a pointer, then we can simply use null. That's what we learned in this video, and we should initialize a pointer with null when we don't have address to be assigned. And we can assign null values like this. And if you print the value stored at P, it will give you 0, but it is different from integer 0. Let's learn about void pointer. It is a specific pointer that points to some data location in memory which doesn't have any specific type. So it is a pointer that holds the address of any data type variable, so it can point to any data type. If we assign address of integer data type, it points to integer variable. If we assign address of character data type, it points to char variable. If we assign address of float data type, it points to float variable. Let's see syntax of void pointer. Void asterisk void pointer name. But void pointers cannot be dereferenced to access the values of variables. For this, we'll have to typecast or type conversion. This is syntax of typecasting. We can use it in printf statement. Let's see one example for this. In this example, there is a variable a of type integer having value 10, and this is a void pointer and address of a variable has been passed to it. Since we have passed address of integer variable, so we'll have to typecast it in int. You can understand it by this example. Now run this program of void pointer where p is pointing to integer, float, and character after typecasting. Now let's see use of pointers. First one is swapping values by call by reference, but first we'll see what is call by value. After that, what is call by reference, and both of these are a way of calling function. Swapping refers exchange of two values. But do you remember what is function and how to work with functions? Let's take a short revision before proceeding. A function is a group of statements that performs a specific task, and it has three parts: function declaration or function prototype, function definition, and function calling. And these are four ways to implement a user defined function that is taught in video number 12. You may refer it. Let's take one of them, that is argument with no return value, where values are passed as argument. This is called actual parameter and this is called formal parameter. Values are passed from actual parameters to the formal parameters. In call by value, when values are passed from actual to formal parameters, values are stored locally to the function in memory location. If we change the values, these are changed for current function only. Now let's see how this code for swapping values works. Temp equal to a means value of a will be assigned to temp, that is 100. Now temp has become 100. A equal to b means value of b will be assigned to a. Now a has become 200. Temp means assign value of temp, that is 100, to b. So now b has become 100. Now you can see values are exchanged, but these values will not be reflected in main function. Since values of actual parameters are copied to functions formal parameters, and the two types of parameters are stored at different memory locations, so any changes made inside functions are not reflected in actual parameters of the caller. Let's run this program of call by value. Let's see the changes made by swapping in function. You can see values has not been changed here. Now I'm printing the values of formal parameters. So compile and run it again. You can see the values had changed, but it is not showing in actual parameter. In call by reference, the address of the variable is passed to the formal parameter from actual parameter. So pointers are used as variables for this purpose because pointers can store the addresses of another variables. That's what we learned in this video. So pointer x will store the address of A and pointer y will store the address of B. Let's suppose these addresses are 400 and 500. Now pointer x will point to A and pointer y will point to B. And now let's see how this code for swapping works here. Temp equal to asterisk x means value stored at x will be assigned to variable temp. Since value stored at x is 100, so temp will become 100. Asterisk x equal to asterisk y means value stored at address y, that is 200, will be assigned to value stored at address x. Asterisk x, that is a, will be 200 now. And asterisk y equal to temp means value of temp, that is 100, will be assigned to value stored at address y, which is b, will be 100. Thus you can see A has become 200 and B has become 100. That means values have been exchanged now. So whatever changes are made in formal parameters, changes are made in actual parameters too. Now compile and run this program. You can see the changes made in actual and formal parameters. Thank you for watching the video, and if you have any query regarding the topic, comment in comment section and do subscribe the channel for upcoming videos. Like and share it as many as possible so that your friends can also learn it. See you in next video.